Divisor game. So to solve this problem, we need to know two concepts: dynamic programming and hash maps. DP is all about building solutions on top of solutions, and hash maps are simply data structures that map keys to values. A key is an identifier, a value is the value it matches to. For example, 1 can match to the name Bob, in which case 1 will be the key and Bob will be the value. Let's see how all this comes together within the example. Now, DP is all about building solutions on top of solutions. So let's start with the simplest cases and build up. What happens when n is equal to 1? Well, by the rules of the game, Alice would lose. So we would say this is a lose for Alice. And what about n is equal to 2? By the rules of the game, what can Alice do? Alice can only choose 1, in which case n gets down to 1. Bob is left with the last one, so Alice will win. What about n is equal to 3? Well, Alice can only choose 1 here, so the number becomes 2. Bob then can only choose 1, and what happens? It means that Alice will lose. Now, what is something that you can see from this pattern? Remember, DP relates previous solutions with the current solution. Well, you see that when n is equal to 3, it depends on the outcome of when n is equal to 2. We know that if Alice is given the 2, then she will win. But the vice versa means that if Bob is given the 2, Alice will lose. So what can we say? We can say that since we know Alice will win if she's given a 2, it must mean that if she is not given a 2, she must lose. When Alice chooses 1, the game gets forced into 2, and we know that 2 is given to Bob. Therefore, we can use this outcome to say Bob must therefore win the game and Alice must lose. Let's illustrate this even more clearly with n is equal to 4. When n is equal to 4, Alice can do one of two things. Alice can either subtract 2, right, and turn the number into 2, or she can subtract 1 and turn the number into 3. Now, when n is equal to 2, that means this is Bob's turn. Well, we know that when Alice is given 2, she must win. So if Alice is not given 2, then she must lose. So this will result in a lose for her. But what about n is equal to 3? Well, when n is equal to 3, that means that she forces Bob to pick 3. And we simply alternate A and B. Therefore, Alice must win. So we see here that every single nth number is dependent on the outcome, the opposite outcome for n minus 1, and the opposite outcome for n minus 2. And that's how we recursively build on top of the solution to get our final result. And with that, let's program it in Python. So again, we need to use hash maps, and the hash map is basically going to store all the key value mappings. The key is going to be the number of n, and the value is going to be the result. So we know from dp of 1, that must be equal to false, right? Because that's given to us, and dp of 2 is also given to us to be true. We use this to recursively build the solution. So for I in range 3 to n, we can do n plus 1 or 1, depending on what suits. Actually, we'll do n plus 1 because this is all 1-based indexing. What we're going to do is we're going to say if I is odd, what must happen? Well, that must mean that dp of I is equal to naught of dp I minus 1. Now, I need to explain this a bit because some people ask me, what if the number is 9? You can subtract 3. So why do we not consider dp of I minus 3? Well, the reason for this is because of how dp works. dp recursively builds solutions. So I minus 3 has already been predetermined, and I minus 3 affects I minus 2, which affects I minus 1. Therefore, we only need to consider I minus 1 to know what the correct result should be, because each subsequent solution is dependent on the previous one. So we just need I minus 1 and nothing else. And what if the number is even? If it's even, then dp of I has to be equal to the naught of dp I minus 1 or naught of dp of I minus 2. Because if it's even, you can subtract 2 or 1. And we illustrated this with n is equal to 4. So this is why we must have this as so. And with that, we can return dp of n to get our solution. So with that, we can run it. And that's correct, so let's submit. And it passes everything, and that's the solution.